So friends, in the previous class, we have studied tensile testing. Now, tensile testing is one of the destructive tests. Excuse me. Tensile testing is one of the destructive testing method in which specimen is held in vertical or horizontal direction and it is pulled axially. So when it is pulled, force is applied away from the center and then the rod gets extended. Because of that, its original length is converted into or increased to some higher length and depends upon how much you are giving tension. It crosses elastic stress, yield stress, ultimate tensile stress. Now, depending upon it, your part is going to be extended in such a way that elongation, it will show the fracture. So there are two types of fractures. One is ductile fracture, another is brittle fracture. Always remember, I told this last time, the ductile material have good tensile strength, whereas compression or brittle material have good compression strength. I repeat, ductile material have good tensile strength, whereas brittle material have good compression strength. Now, when you are going to find out the elongation or fracture of ductile material, how it breaks, figures were drawn by me last time, this side, and typical ductile fracture. But when it is a brittle fracture, when you try to elongate, it will not show much elongation and it will show sudden cracking. And I made one statement during that class. Ductile material shows ductile fracture. Brittle material shows brittle fracture. But many times or sometimes ductile material shows brittle fracture. Ductile material shows brittle fracture under three conditions. Susceptibility of material, ductile material, for brittle fracture can be studied under three conditions and it is under impact test. So impact test gives significance of expectation failing. Impact test gives the failure of ductile material in brittle manner under different conditions. How? Let us see one by one. Write down this. Impact test is used for studying the failure of ductile material with brittle fracture. Ductile material shows, you write down in this way. Ductile material shows brittle fracture. Ductile material shows brittle fracture under three conditions. Under three conditions. First condition, triaxial state of stress. Second, low temperature. Third is sudden load. Brittle fracture, three conditions. First, triaxial state of stress. Second, low temperature. And third, sudden loading. Now you know very well What is ductile fracture and what is brittle fracture? Ductile fracture means what? When you are going to elongate, it will show cup and cone type fracture. It's like this. So this is elongation and this is neck formation. And this is brittle fracture. So ductile fracture is usually with some gradual loading. It shows cup and cone type fracture with neck formation. In brittle material, there is no neck formation. Now, ductile material must fail in this way, and brittle material must fail in this way. But ductile material sometimes fails in this way. How? These are the conditions. Let us see one by one. After this, you write down the statement. Impact test. Is used to measure impact strength of material. To measure impact strength of the material. I repeat once again. Impact test is used to measure impact strength of the ductile material under above conditions. Now see, what are the above conditions? Triaxial state of stress. Usually in tensile testing, there is a biaxial state of stress, means one side, another side. If your material get tensed in three directions, so it may fail suddenly. Now, at actual, we cannot create such conditions, but during working, many times your component may come across the different loads from all the directions. In that case, your material may fail suddenly without showing signal. This is signal. This is no any signal. This fracture gives or causes accidents. Here you can stop the machine. You may hear some misalignment sound, something, etc. Now, you have studied the concept of design of shaft or design of many components. Whenever any component is to be designed, so that component is tested for number of strengths. What is its tensile strain? What is its impact strain? What is its fatigue strain? Suppose I have taken one material and I have tested the tensile testing. So I have prepared the specimen, the shape of the specimen I have shown last time. I put on UTM. UTM is Universal Testing Machine. So there I have and carried out the various properties such as yield point, ultimate tensile strength. Ultimate tensile strength is 385 millimeters square. Suppose this value I have by tensile testing. Now, what is meaning of this? Ultimate means during working condition, your material will fail only you are reaching near to or more than this value. Try to understand the concept. The meaning of ultimate tensile strength is your material will fail when your stress value during working condition will reach near to it or more than it. Actually, it starts failing above yield point only because it shows plastic deformation. Once there is a plastic deformation, there is a misalignment, etc. Now, as far as this value is concerned, we should not stuck up this value. You are considering that the part which you have designed may be under tension always. But during working condition, you can't predict this may come under any of these three conditions. At that time, you can't keep faith on this value. You may observe that at 200 Newton per millimeter square, part get failed. So you may be under impression, I am design engineer, I have designed it, how it fails at 200. That is not in your hand. Because when you are working or when you are putting this part in the working condition, it may come across many of the cases out of these three. Any sudden loading may be there. Your part may come across the very low temperature, maybe less than 0 degrees Celsius. It may come across any number of sudden stresses from all the sides. That's why one way your step number 1 is over. 385 Newton per millimeter square value you have calculated means your design is not over. You have to check the values for other conditions also. And then finally, at end, you should declare that this is the ultimate value. So by maybe only tension, maybe tension impact, maybe tension impact fatigue, creep, this part will not fail below this value in this way. Now let us see one by one. Triaxial state of stress I explained. Part may come across the number of stresses from all the sides. What is low temperature? So you might have experienced. I will tell one local example. You take one piece of metal, maybe MS. Take one nail. Take two nails. One nail you keep as it is in the atmosphere. Another nail you deep freeze. You have a refrigerator, so put in the freezer. Let it be cool, maybe 4 minus or maybe 4 degree, 3 degree. Industrial freezers you have seen in the shops where the ice creams etc. are stored. There you keep. They are called as deep freezers. So in that freezer, if you keep that nail for some particular period, maybe 1 or 2 days, you do an experiment. Take nail which is in the atmosphere, put maybe on some hard surface and give the impact by hammer. That nail may try to penetrate in that hard surface. If the hardness of surface is less, nail may go inside that. If hardness is more, what will happen? Nail may get bent. Nothing will happen more than that. Either go or penetrate or bend. The nail which is outside or outside the freezer in the atmosphere. Same experiment repeat. Take the nail which is very deep freezed for 3-4 days and take it outside and immediately put on a hard surface and give the impact. You will find only one option. Depends upon how much deep freeze you have. Okay. And depends upon strength of that component. One of the option is that your nail get break into pieces. Your nail get break into pieces. Means what? It is a brittle failure. Why? Because whatever impact you are giving on the nail, that impact will cause failure of that nail by breaking into pieces. This is brittle fracture. So bending will be for earlier case and same nail, same material break. Why? Because it becomes extreme brittle because of low temperature and ductile material fails in brittle manner. That's why, friends, the vehicles which are designed specially in the snow area, maybe army vehicles or the regular vehicles which are used in Ladakh and maybe other snow areas, maybe foreign countries like Switzerland, etc. Your regular automobile parts are having some different material, but the automobile parts which are used at or in the vehicle used at snow areas are having little higher strain. Some connecting rod which you are using on your roadway vehicles, same materials connecting rod may not be used there, which is continuously in the snow. Continuously, I'm saying. If 1 or 2 times it is going and coming back, no issue. But 24 hours it is in that minus 10 degrees Celsius, Siachen or Ladakh. In that case, your regular component get failed. That's why some specially designed materials are used which may have good impact strength. Now we are understanding the meaning of word impact strength. Impact strength means good shock absorbing strength, which can sustain the shocks, which is having good toughness. Very simple. So which property is measured in the impact test? Toughness, energy absorbed prior to fracture. Very simple. I repeat once again, in tensile test, number of properties are checked. Yield stress, elastic stress, yield stress, ultimate tensile stress. Then toughness is also measured, area under stress circle I told. The resilience is also checked, percentage elongation is checked. But impact test is used for checking the toughness. And this is now relative toughness. Many times questions were asked in the examination. The following test gives true toughness. Following test gives relative toughness. Remember, it is very difficult to find out toughness from tensile test because you have to measure the area and calculations you have to make. So to save that, impact test is designed so that it will give the toughness with some small calculations. Definition of toughness is energy absorbed prior to fracture. So such components which are used in the low temperature area must be with good impact strength so that they can sustain the shocks. Okay? Now, concentrate on this. We are going to perform experiment on this sudden loading. You can create the situation 1, create the situation 2, or create the situation 3 for checking the brittle failure of ductile material. Take once again you can do the experiment. Take one wire, thin wire, hold it in your hand and slowly extend. Now for safety precautions, wear the gloves. Okay, otherwise there may be injury in your hand or fingers. Hold it, take some sufficient length, 100 to 100 mm, and slowly apply the force. What will happen? You will find that wire is elongating. Wire is ductile material, no doubt, because of only ductility property you can draw the wire. So it is made up of ductile material. So if you apply the gradual load, you will find elongation in the wire. Same wire, after some elongation it will break. Now take second piece of the wire. Same wire, same material, hold it, and now after holding at sufficient distance, just say 1, 2, and 3 and give sudden impact. If you give sudden impact, you find that wire gets break into pieces. Depends upon the whatever individual's health. Some person may get breaking it just by doing in this way. Some may require more efforts, but it will break. That is brittle failure or brittle fracture. Ductile material fails in brittle manner due to sudden loading. So friends, ductile material fails in brittle manner by 1, 2, 3. Now if you have designed the component, 385 is ultimate tensile strength, and you are putting it, that part may be under tension somewhere, and sudden loading will be there. You can't imagine when sudden loading will come. In that case, your 385, it is long, or sorry, it is a, I'll say long step, or it will be very higher value in that case. Because of sudden loading, your component may fail at 150 Newton per millimeter square also. So that can't be predicted. So this is the impact test significance I told. How it is carried out, what is the name of the machine, what are the specifications of the specimen. Almost all these questions are asked many times in MCQs, interviews, as well as theory examination. So next line after this, you write down the impact testing procedure. Impact testing procedure. One more example of low temperature I'll give. I'm not remembering the name of one Bollywood, not Bollywood, Hollywood movie I have seen during the traveling. I used to tell this example to every time to our students. So there was fight between two people, and suddenly they came in some laboratory. This was chemical laboratory, and one person hold the neck of another opponent, and he opened one cap lid of the tank and dipped his complete head into that tank. That person gets die immediately, immediate death because of he can't breathe. Okay, and now he used to take him outside and just impact on the wall. What will happen? Like cartoon movie. In cartoon, what happened? Many times you have seen that Tom and Jerry cartoon. ते टॉमचे तुकडे तुकडे होते सगळ्या शरीराचे परत ते टॉम तयार होते. Same way, that person's complete head get break into pieces. Why this is happening? There is a theory behind it. In cartoon, that is just for enjoyment. But here, what explanation I am giving, what situation I have explained, the person holds the neck of one person deep into some bath, and that liquid will cause his complete head becomes brittle, so brittle that with just impact, complete head break into pieces. Can anybody tell what may be that liquid? Can anybody tell what may be that liquid? Anybody is having idea? It is available. It may not be available to you easily, but it is available. That liquid where the head is dipped and was dipped, and it becomes so brittle. Can anybody tell? Temperature is minus 183 degrees Celsius. That is liquid nitrogen. You might have heard the concept cold burning. How many of you heard the concept cold burning? Somebody reply, you are not giving answer to my questions. You have to unmute and explain. How many of you know the concept cold burning? Hot burning everybody knows. Cold burning. Any idea? Anytime you have heard? So participation is required from your side. What is chatting? No idea. I'll tell. See, you might have experience. If you just put your hand in the freezer, you may find it becomes so cold. You'll become uncomfortable. The temperature inside your freezer is just 5 degrees Celsius. Even you hold the piece of ice for a long time, you feel sensation. So that is disturbing you. Okay. Now imagine any of such liquid, minus 50, minus 100 degrees Celsius, such drop, it will fall on your hand. So your sensation will be so, it will be headache to you. You find it is like burning, but it is cold burning. The feeling will irritate you, and you may feel it is like burning, but it is not burning your skin actually. But because of this so cold temperature, if it will come in contact with your skin, you'll become uncomfortable. You'll feel uncomfortable, and that situation is called as cold burning. You can see, just hold your hand in the freezer for 2-3 minutes. You feel uncomfortable. And imagine such a drop of the liquid nitrogen minus 180. So every liquid air, these are liquids. So normal circumstances or normal situation, this is air. Nitrogen, you know that we are observing 71% nitrogen almost in the atmosphere, 78%. But when it is condensed, liquid will be at 183 degrees Celsius. That's why at such very, very low temperature, your human body will also become brittle. Are you getting? That's why that hair was broken into pieces. Now, we are going to study the impact testing. There are two types of, before that, I will show you the setup. There are two types of tests. One is Ch5 Impact test. Write down this. Another is Isode Impact test. These are the name of technocrats. Same machine is used, only different specimens and conditions are there. Before I explain it on comparative basis, let us see how the machine is. I will draw the schematic diagram. You also draw along with me. Impact testing machine. I will erase it afterwards, but I will draw here. Draw this. we are going to perform experiment on it. Simple mechanism, one horizontal bar. Actually, it is horizontal or inclined. That I will show you later. Because for isode, it is horizontal, and for Ch5, it is little inclined. What is the difference? That I will tell you. So, this is one bar, this is hammer, and at center vertical position, your specimen is kept. Okay, and this it will leave from the higher position and it will come down. So just I will show in this way. It is horizontal position and it will come down. Now it is vertical position. Okay. Here is the specimen. When you are leaving it from height, it will strike to specimen and specimen will be breaked. And after breaking the specimen, this hammer will reach to H dash. Here is H dash. H dash. So original height and final height after breaking. It is like pendulum. Specimen is kept here. Now, if same setup is used by Ch5 and isode, if it is Ch5 test, this initial position H is little different. So, by virtue of H, it has which energy? L. mgh. mgh is nothing but what? Potential energy. And here it is mgh dash. Now, if Ch5 test is there, initial energy is 360 joules by calculations because machine is already in existence. Weight of the hammer is also known, mass. G you know, and H is also fixed. So that value is 360 for Ch5 test, and this value for isode test is 162. Now, these are the initial values. You are going to keep the specimen here. We are going to find out what is energy absorption capacity of the specimen. So you have to mention whether you are how I am measuring the distance. You are measuring the distance in feet or inches. You are mentioning clearly. Similarly, you have to measure the energy absorption capacity in joules only, whether you are measured by Ch5 or by isode. Okay. If suppose I am using the Ch5 test, specimen is kept here. Now, how the specimen is? So, Ch5 test and isode test, there are variations in the size of the specimen, presence of notch, and shape of the striker is different, and position of the specimen. So, question may be asked in the exam, what is impact test? Explain Ch5 and isode impact test. Or, many times it was asked, differentiate clearly between Ch5 impact test and isode impact test. Or, draw the net sketch of specimens of Ch5 and isode impact test with their positions. Now, we'll make two parts of the notebook, left hand side Ch5 and right hand side isode. So, simultaneously, I will explain to both. Experiment procedure is same. Specimen is kept here, and then you are going to leave the hammer from the higher height. Because of this height, it has some potential energy. And if you leave it from there, it will break the specimen and it will go to H dash. Now, I will show initial energy. Initial energy equal to energy absorbed by specimen plus final energy. Write down this formula. Initial energy is equal to energy absorbed by the specimen plus final energy of hammer unit. Initial energy equal to energy absorbed by the specimen during breaking. That word is important. Energy absorbed by the specimen during breaking plus final energy of the hammer. May I erase this figure? Please reply. May I erase this?
Yes, sir.
Next line.
Yes.
Energy absorbed by the specimen during failure. This you take here. Energy absorbed by specimen during failure equal to, right, full form. Energy absorbed by specimen during failure equal to initial energy minus final energy. Both are potential energies. Equal to mgh minus mgh dash. Now, what is energy absorbed by specimen before failure or during failure? It is toughness. Definition of toughness itself is energy absorbed by the specimen during failure. Then toughness is equal to mg in bracket h minus h dash. So during experiment, what you are going to measure? Tell. M, you know, hammer is fixed. Hammer and its assembly with striker. Striker means inside the hammer. I will tell you what is meaning of striker. So this is your specimen. Some metallic part is there which will cut the specimen. So inside the hammer, one extended edge is attached. That extended edge is called a striker. G is fixed, H is fixed. Only H dash you have to measure. If you measure H dash, you will get the toughness. Now just imagine, I have erased the figure. You go to your figure and imagine that this is the pendulum. Okay, horizontal position. It will come down, it will break the specimen and it will oscillate in this way. It is not going to stop. So it is going to oscillate. So how it is going to stop? If it will not stop, how can you measure H dash? Within fraction of second, it will come back to the initial or previous direction. And in this way, it will go on oscillating and then slowly it will remain steady. Then how to measure H dash? So for that purpose, in your figure, you have written pointer. Just check your figure. So this horizontal rod is connected to the pointer. As soon as it will reach to H dash, pointer will show the value. And directly on machine, you will get H minus H dash into mg. Direct value of energy is shown on the machine. This is the measurement of toughness. Energy absorbed prior to fracture. You can write star, make star mark and write impact test is used for measuring the toughness. And it is a relative toughness. Make double underline. Relative toughness. Because true toughness is measured by tensile test. Now go to next slide. Make two columns. left hand side Ch5 impact test, and right hand side ISO impact test. CHARPY and IZOD. IZOD impact test. So procedure is same for both, only change in the specimen. The specimen, one by one you write. Specimen. It is square cross section 10 by 10 and 55 mm length. Square bar 10 by 10, 55 mm length. Here 75 mm length, 10 by 10. Second, notch is at the center. You have to modify the figure like that. Draw the notch. That is a point of difference. That's why I am asking to write the second point. Notch is at center. And here, notch is away from center. 27, 48. Second point of difference is notch is away from the center. Third point of difference is specimen is kept horizontal during the working. I will explain this, how it works. Specimen is kept horizontal during working, and specimen is kept vertical during working. Write the statement. Specimen is kept vertical during the working. Now see what is this. I will explain you. Next point I have told, notch is away from striking end. In Ch5 impact, notch is away from striking end. And here, notch is towards the striking end. Check. This is striking end and notch. And this is notch away from striking end. And last point, you write difference and then I will explain. Here, striking edge is vertical, left hand side in Ch5 Impact. Striking edge is vertical, and right hand side, striking edge is horizontal. Now within 1 minute, I will repeat the points of differences. Check whether you have written correctly. First, specimen is 55 by 10 by 10. This side, specimen is 75 by 10 by 10. Okay. Now figures of the specimen you have to draw. 55, 10, 10, 75, 10, 10. This is point 2. Then notch is at center, and here notch is away from the center. Third point after figure. Then here you have to write specimen is kept horizontal during experiment. Specimen is kept horizontal during experiment. And here you have to write specimen is kept during the experiment. Specimen is kept vertical during the experiment. Next, notch is away from the striking end. And here, notch is towards the striking end. It is shown in the figure. And last point I told, the edge of striker is vertical in Ch5 test, and edge of striker is horizontal in ISO test. Now pay attention. I require 100% attention. I will take this cap of the pen. This is your specimen. Now imagination is required. Machine is not in front of you. You have to imagine. It is type of pendulum. Okay. Now in Ch5 test, specimen is 55 mm length, 10 by 10 cross section square, and notch is at the center. How it is kept? It is kept horizontally in this way. Now you have to observe from top side. Horizontal means you have to observe from top side. Okay. I can't show in this way, it becomes vertical. Horizontal is in this way. Okay. So when I hold it in this horizontal position, this notch is this side, my right side. Okay. Notch is this side and striker is at this side. Notch is away from the center. Same position. Okay. This is having the notch here, and your striker is in this side, in that hammer, and edge of the striker is vertical. See my palm. हाताचा पंजा बघा. ही एज आहे ती वर्टिकल एज आहे, किंवा हे बोर्ड बघा. ठीक आहे, ही वर्टिकल एज आहे. हाताचा पंजा म्हणजे हे बेटर एक्सप्लेनेशन आहे. असा स्ट्रायकर असतो इथे, आणि हा स्पेसिमन असा आहे, आणि हे असा ह्याला इम्पॅक्ट करतात. सो एज ऑफ दी edge of the striker is vertical in this way. So it will give impact like this. It will break and it will go up. Second condition of ISO. Specimen is not kept horizontal. Specimen size is now 75 by 10 by 10. It is kept vertical. See here in this way. Now specimen is vertical. Hold in this way. Now same striker if I use as that of Ch5, that is vertical edge, what will happen? There may be slippage of the edge on the specimen, as specimen is also vertical and edge is also vertical. So that's why in ISO test edge is made horizontal in this way, and it will come and it will impact in this way here, and that is notch position. Notch is towards the striking end. Here striker impacts at the back side of notch, and here striker impacts at the upper side of notch. Okay, so this is called as the position of striker. So I have explained you, notch is towards the striking end and notch is away from the striking end. Now some basic questions. You can consider it as a interview questions. I will ask one or two cases. May I erase this? You tell me.
Yes, sir.
Now, please listen carefully because this is overall interview question. This is your original position of the hammer. I have shown this hammer. Specimen is kept here. Now, case number 1. This hammer will remain here itself. Once I will leave from here, I leave it. It is locked in originally. When I am going to start the machine, I have to remove the lever. It will immediately come down because of weight. And case number 1, I told, it remains vertical. Means what? Tell. Because specimen is kept here. During working condition, during experiment, this hammer just remain vertical. So this is H. Then if this remains vertical, means what is H dash? Answer it. What is H dash? Somebody answer.
0.
0, sir.
Correct. Very simple. So what is toughness? mg h minus h dash. So what is toughness? mg h minus 0.
Yes.
So what is formula? Toughness is equal to energy absorbed by the specimen during failure plus final energy. Wrong. Are you awake? Just I am checking. Energy absorbed by the specimen itself is toughness. So total energy is equal to energy absorbed by the specimen plus final energy. But energy absorbed by the specimen itself is total energy. Means all energy is get absorbed by the component. Means toughness of this specimen is more than this inertial energy. Specimen will not break. That's why H dash is equal to 0. All energy is absorbed by the specimen. Case number 2. This hammer will come exactly here. H dash is equal to H. Tell me what is toughness?
0.
0, sir.
Means no energy is absorbed by the specimen. Case number 1, toughness is maximum. All energy is absorbed. And case number 2, no energy is absorbed. And if H is exactly equal to H dash, there is no specimen. If some specimen will be there, at least 1% will be absorbed by it for breaking. As there is no specimen, H becomes H dash. Are you getting my point? I hope you are getting it. Now, important thing. Why the notch is provided? Why the notch is provided? In machine design subject, there is one concept, notch sensitivity. Remember, if I will not use the specimen with notch, it will give me some impact strength, energy absorption capacity. Suppose it gives 200 joules. So I can conclude that this specimen have 200 joules energy absorption capacity. Up to 200 joule, it will sustain the impact. More than that, it will break. Now, this is your prediction as a design engineer. Now, same specimen you will use in the component. But whether that is so plain, no. It may have keyhole, it may have oil marks, it may have grooves. So in such case, your stress concentration increases and component may fail less than 200. So the situation like keyholes, oil holes, grooves, stamp marks is represented by notch here. So susceptibility of material for failure in presence of notch is called as notch sensitivity. That's why intentionally we are creating the notch. I hope you are getting the purpose of creating the notch. A plain rod you are using, but in actual condition your rod, when it is acting as a shaft, it may have some stamp mark, it may have some keyhole, that because of stress concentration it may fail earlier. Understood? So please remember, bottom line I will tell, last 2 minutes are remaining. Toughness is energy absorbed prior to fracture. It is relative toughness obtained from this impact test experiment. So the specimen which you are using is of MS, mild steel, ductile material, but it break into pieces. Same mild steel was used in tensile test, it was showing elongation. Now we have changed the shape and it break into pieces. So ductile material fails in a brittle manner, checked by this impact test. Okay? So in next lecture, we will study the next destructive test, that is fatigue, also hardness test, and then fatigue and failures. We will stop here. Thank you.